First of all, as always, huge thanks to our sponsors. They're doing an amazing job. We wouldn't be here without them. They make sure everything runs fine, and go out and check out their products. They are quite amazing, and they are really super good people. My name is Björn Sundling. I am an Azure and DevOps consultant, which means I do a lot of Azure DevOps consultancy at Advania in Sweden. I am an MVP since a couple of weeks ago in developer technologies. I write stuff at bjompen.com, have a GitHub page and Mastodon because I left Twitter some time ago. Dogs, guitars, lots of fun stuff I do. I love to cook food as well. Feel free to ever come to Sweden, if you ever come to Sweden, to come try my food. Today, the agenda looks a bit like this. First, what's up with the title, PTMF? Very short, just a brief explanation. And then we're gonna go deploy an Azure function. Now, let's be clear, this is not an Azure function session per se. It's just a very good scenario for the demos that I wanted to do. So we're gonna do some building of our code. We are going to set up some infrastructure, and we are going to run dev test prod deployment minus the dev, because it didn't really make sense to include it. It's kind of obvious, I think, in the end. So, push to main Fridays. Well, that's what it stands for. It comes from my work, where we, a long time ago, everyone, you always say, when you're a developer, everyone always says, you should never deploy on Fridays. Never deploy on Fridays. Deploying on Fridays is bad. You spend the weekend doing bad stuff. But I started thinking a couple of years ago, because I thought this was a really weird way of thinking about it. Like, why not? If we deploy on Friday and things go south, isn't the issue actually with our pipelines and the stability of our product? And shouldn't we fix that enough to start deploying on Fridays? And we started sort of doing this at my work as a thing. Deploy whenever, wherever, just deploy. Things went terrible. But we also learned that if we do it the right way, if we actually start to fix stuff, then things work better eventually. So, a saying at my workplace, push to main Fridays, push to main every day. That's the short of it. So, last year I gave a presentation called PTMF. It kind of ended up with us creating a CI pipeline. What does this consist of? Well, the things you need to start deploy stuff. You need, before you even start to think about what we're doing today, to set up proper integration. You need to have your linters in place. Make sure that the code looks the way you want and actually behaves the way you want. And like most of us have rules that we want coders to follow. You need to have your tests. In our community, that's Pester. You need to have proper test coverage. Because if you don't, well, you're gonna have a bad time. And security scanning or whatever, most companies I work with at least require some kind of security, SAST, DAST, password, secrets, whatever, scan for something. And last but not least, not in this list, by now, before you do this, you should have a Git strategy. A strategy for how you manage your Git repositories. Hopefully, you set it up using policies, which you can do in just about any Git platform. If you trust your developers and your colleagues enough, just say this is how we should do it. And why do we need this? Well, we'll get back to this later. So the focus of today, of a CD and actually moving from just writing code and sharing code to actually deploying stuff into production, having stability all the way. The focus can be boiled down to 3 keywords. Stability, repeatability, and frequency. And we will get back to those 3 words in the very end of this session. So, that said, let's head on to the fantastic world of CD pipelines and PTMF part 2. So, where do we start? In the correct tab, of course. Like I said, before you even start to do anything we do today, you need some, oh, sorry. If I do that again, please shout. Like I said, before you do anything, before you even get started, you need to have some standard setup for your baseline repos. Like your main code repo, main code branch should have at least a couple of steps included. Whoop, that's too big. It's really hard to zoom on this one. For example, I run my own secret scanner because it's cool and I can advert it on conferences. But like I said, script analyzer, run your linters. Script analyzer tells you like this, you shouldn't allow unencrypted passwords to be sent to your functions. Make sure that everything looks okay. Needs to be run. Pester tests. You should have not 100%, I don't have 100% in any of my repos, but at least a decent enough test coverage that you can trust that the things in your main branch is stable enough to be deployed. Otherwise, you will have a bad time. The last step in our CI pipeline, publish the test results because we like reports, managers like reports because it's fun to see. This one you don't have to do unless you want to. This said, the first thing we're going to do, deploying our Azure function, is add a build script. A build script is not needed at all in PowerShell. We all know that you can write a module by hand or with your editor and you can import it and so on. So it's not necessarily needed to have a build script because we don't build, unless you were in the session earlier teaching you to build with C#, whereas you actually do need a build script. But building adds another layer of good stuff to what we do, of stuff that we should do, stuff that we need. So it allows us to create a single package that we then can use in our pipeline, in our deployments all the way through. We need to have an artifact that we can follow all the way through from the start to end to in our pipeline. It's also the last chance we have to check that stuff actually works and behaves. As for me, I use Invoke Build. Most of the demos here, by the way, that I will show, most of the code I will show here, is just one way. It's just one way and my way. You are free to do whatever way you want, and the steps you include will be different. Anyhow, I use Invoke Build by Roman Kuzmin. I hope I pronounced that right. This is a build tool that's absolutely magic. It can do all kinds of cool stuff, and I have no idea about half of them. But basically what you do is create tasks, and then you run tasks in the very bottom. So you say, for example, we start by cleaning. Oh, we start by, where are you? There. Cleaning, this is the output directory. Make sure that there's no residue in our output directory. We run our unit tests. But why, Björn? We already ran our unit tests in the main branch. Well, yes, but I can't be too secure, right? Or too sure that everything works, right? Just take another chance. Run them again. We run script analyzer. But why, Björn? We just ran a script analyzer. Yeah, same thing. If you have documentation, build it, do whatever you want. The main point, the important point, I'm not going to go through the entire building script here because it doesn't make sense. The main point is the result. This outputs one single blob, one single PSM1 and PSD1 file that I, again, run my unit tests against. So I actually have a compile module build step, or compile module, and then I have a unit test for compile module. Because once I've taken these parts of code and puts it into my built PSM1, I want to make sure that that one works as well. And this should hopefully end up in something like this. A compiled module where every single file, every single whatever class, whatever it is you're building is included. This makes it, it's not necessary, like I said, but it makes it a lot easier when we move on. So again, I'm not going to go through the build script itself, but I do want to show you some cool stuff that we can use here. So one of the things we need to do when we build our module is version it and tag it. You can do this in a number of ways. Module manifests have a version number that we, of course, should bump and make sure. And there's a really, really cool tool that we can use to do this. If you were in Rob's session, I actually just walked by the door and was like, hey, I know that screen. And it's actually this same thing that I'm demoing right now. So if you were there, you probably saw this right away. There is a cool little tool called Git version. This is included in most build agents. Wherever you build, if you're running self-hosted build agents, well, download it. It's a single exe. If you're running Linux, it works there as well. And running it just as it is outputs a lot of data in JSON format. As we all know, JSON format is nice and easy to work with in PowerShell. The important thing here to note is this one. Git version counts in this very, very simplest form. It counts your commits and gives you a sort of, this is how far you've gone in your release cycle. So just running it as is, you can use this output, convert it back from JSON, and tag your packages and say, oh, this is the version of my module right now. It also accepts config files, so we can do get, sorry, we're gonna go clear first. Get content. Git version config. You can use a whole lot of more metadata in this. I just picked the biggest or the simplest one, just set the main, a major version, and we can give it a git config git version, thank you, /config, that's where I got it confused. Git version.config.yml. And since I set a major version in my config file, it will now start counting from major version 3. You can use this to automatically update your tags and set your module versions and do all kinds of cool stuff. If you're feeling really advanced, if you're sort of used to using Git regularly, if your team is ready for it, and if you have that Git strategy that I just noted that you need to have, you can do this magically with Git tags. So that, okay, we tag one with this is a major release, this is a minor release, this is whatever release. And Git version will count every single commit for you and do this magically, and you just get, this is the version in semantic versioning that you should tag your package with. So use something like Git version to tag your built packages, no matter what they are, what they consist of. You can also, if you are, again, using C# or F# or whatever, you can actually inject versions into the manifests. So when you build stuff in those, you can just say, Git version, make sure to tag my release with this number. Really cool tool. Before I leave my console, because this is the only one I have in the console, only demo, I have had a lot of questions every now and then. I couldn't really fit it into the demo workflow, but I really wanted to show it. A lot of questions. Okay, I have many projects. I have many modules in my repo. I have many files in my repo. How can I know? Why do I need to rebuild and release everything every single time? No, you do not. Git can handle that for you. Git, let's see my cheat note, because I am bad and keep forgetting stuff. Thank you. Git diff head roof -- name only. Okay, in this case, I just had one file. This command will output every single changed files, just the names. So you can say, if you're using subfolders and have one module in this subfolder, one in this, and one in this, and so on and so forth. This and a bit of PowerShell magic makes it quite easy to just pick a small piece of your code and just build what you actually need to build, or release what you actually need to release. So, good. Thank you. I actually said, oh yeah, one small note is, like I said, I use Invoke Build, really good tool. But if you run it in your console, it has the fantastic functionality of always ending with exit. So it will kick you out of your console if you run it. So if you have your history and everything. So yeah, fantastic feature, but that's the way it is. So add your build scripts. If we go to the pipeline, thank you, and add this to our pipelines. In order to run Git version, well, in Azure DevOps, they actually changed a setting quite recently. It pissed me off quite goodly because they changed how Azure DevOps checks out code. So you have to add this one, check out fetch depth, fetch depth 0. Otherwise, Git version can't count because it will not check out your entire history and you will not know how many commits you have. So this is just a quirk of it all. As for doing stuff, well, of course, we run Invoke Build because we need to. We also need to install the module because I don't have it on my runner agent. And the last step in this adding our build is outputting it to a pipeline artifact. Like I started with saying, the point of all this is to have a consistent package to work with all the way from start to end. You need to have one single release. And we can't have that if we allow someone to push code into our tester. If someone has the possibility to change our code or change our functionality once we started the deployment, then we don't know if the deployment will end up with the same code that we started with. Build packages. Use package managing systems to store them in between every part of your step to make sure that you use the same things all the way through. Okay? All good so far? Good. Like I said, we are creating an Azure function. Those run in Azure. That means we need infrastructure. We need to add this to our pipeline. There has been a number of presentations here on various ways of managing infrastructure from starter to quite advanced, really lots of good stuff. I, for one, use Bicep to deploy my stuff because I will mostly work in Azure, so it makes sense. And I go for storing it in a separate repository. Why is that? Well, back to the whole storing packages. We need to also consider life cycling. We can use this code to deploy Azure functions in 1, 2, 3, 4, 10 different Azure functions. And we probably have kind of at least standards to do this. So I do this mostly because it makes sense to me. You can have everything in one repo. You can separate repos out. Why do I use Bicep? Well, because it's idempotent. I can deploy my code using simple parameters, and I can deploy it 1, 2, 3, 4, 5, 6, 7, 8, 10 times. It will only change when something changes. So I can deploy my Azure function to production, and if nothing changed, this will just go, okay, good. No need to restart, no need to do anything because nothing changed. I also can use it to deploy test environments. So if we go into our code, what happens when you produce a pipeline artifact? Well, I actually cheated a bit, so I commented all of it out. Like I said, the last one, building, ends with publishing a pipeline artifact. Next step, we'll download that artifact to the next job, next step. Because for now, we're going to run internal build hosts instead of external. I can do the building on an Azure hosted one, but when deploying Azure functions, I need someone with access to deploy infrastructure. Use internal build hosts. VM scale sets are greatest. And you can use managed identities to do all of this. Not going to go into details, but do it. It's well worth the time and investment security-wise. In this case, since we're running internally, and I'm too lazy to set up an image builder setup that actually hosts everything, I'm just going to run it on a vanilla Ubuntu. So we need to install our dependencies, like install PowerShell, install whatever, whatnot. I need Bicep because I'm deploying Bicep. Makes sense, right? So we're going to continue our building process. Right now, our build only consists of our module, right? But an Azure function requires some more stuff. Oh, come on. Brain freeze. There we go. Azure functions require some more stuff. Apart from the actual module, we need a way to run it. An Azure function contains a couple of different files. You have a host file with some random host configurations. I haven't even touched this one. This is basically the default setup if you create a new function. We also need a function JSON. That's the actual function configuration. And we have a run.ps1, which if you went to one of the sessions I showed earlier, they showed quite good how you can use. This is the actual code being executed in Azure function. This one, it will import my module that I just built and created an artifact from. And it will run it with parameters or without parameters, depending on how we call on our Azure functions, using bodies or using query strings or whatever. Azure functions are quite cool in that way. They are flexible. And it outputs whatever the module outputs. So we have all kinds of cool files added to our repository to deploy an Azure function. Another thing that I often go for here, and again, this is not necessarily best practice, dependency modules. We need a lot of stuff to deploy an Azure function, or a lot. We need 3 modules to deploy an Azure functions. We need to be able to log into Azure. We need to be able to create the resources, and we need to be able to create websites, which is what an Azure function is. And if we go back to the whole concept of building, storing blobs and actually being able to redo this, let's restart that sentence. If we want to be able to redeploy and have the consistency and be able to add the frequency to this, then we need to know that wherever we deploy will look the same all the time, right? This is also an issue if you're working with high security companies. I have customers that requires me to tell me exactly they can go back. So the umpteenth of October in 2011, which dependencies was running in that environment. Well, it helps if I have the blob store with actually containing all those deployments and every single. So I include everything here. Not because it's needed, but because it's useful. Of course, you could use caching services, blob storage, extra, put it somewhere else, absolutely. But include whatever is needed, wrong button, in your repo. Once we have added all of this, all the code, let's go to our pipelines. Oh, wrong one, that one. It's time to do some fun stuff, not just building. So why do we use idempotent? Why do I use bicep? Well, a lot of code in here, but what we're actually doing is generating a random named Azure resource, setting up the entire environment just as it looks in production, because we are using the same templates all the way. We can reuse our templates, we can set up an environment that looks the exact same way, and we can run integration tests. Because again, without tests, you're gonna deploy bad stuff quicker. And in this case, since we have not just our PowerShell code, we tested our module already, but we have a runner. And we have added the run.ps1 and the configuration. So we need to verify that all of this works together as well. Ergo, integration tests. Before we go in and look at the last step of this, how does this look? Well, it's not that much to look at really, a lot of text. Nope. But I just randomly created a GUID, create a new resource group, set up an environment that mirrors my environment totally, completely, run integration tests against them, and if everything works well, we can just destroy this one. The total cost of running this entire integration test that looks like my production environment is, well, less than 1 öre in Swedish. My Azure account, it doesn't even move. It's just totally free. Problem with this is this part. It does take a bit of time because the free versions of Azure functions aren't that slow. They have cold starts and so on. So you can, it takes a bit of time, but it works. And I now know that my Azure function works exactly the same as it will eventually when we get to production. This is also the place where we we should start thinking about adding stuff like Azure load testing or Azure chaos engineering. Sure, it works well when everything works well, but let's say instead of calling just my module calls an API. So what happens if we start hammering this with 1 million hits in a minute? Will the API go bonkers? Will our storage behind it that does the caching go bonkers? Do all kinds of cool testing in here. And if one test fails, stop the pipeline, because it's still just an integration test environment. We could also say something like, in this step, the remove temporary resources. Well, again, if something goes wrong, keep the resource, and we can go in and check what went wrong. We can go back and see all the history of what went wrong. But if everything works out fine, come on, internet. We're going to go back to the publishing of packages. Nope, there we go. Azure DevOps has a really cool feature called universal packages. It's basically a blob storage where you can toss a zip file, or you just say upload the contents of that folder. And you can have a retention policy of anything up to years. I don't remember exactly. You could also, instead of being a bad person like me, I just opted for versioning them by patch number. We could actually reuse the git version tag that we published our module under and say, publish this one with the git version of our published module that runs the Azure function that we have tested, the blobs and the reusability again. So what does this do? Well, instead of a pipeline artifact where we picked between the 2 first steps, simply allows the next step to reuse this. It has a retention policy of 3 months default, and after 3 months or whatever you set up, the package is gone. This one creates an external package. Thank you, internet. An external package tagged with our version number. You can go in and download this. It's just a command line. And it gives you a zip. And since I cloned both my repos with my bicep code, and I had my run.ps1 and everything else I needed, and I have my module, if someone comes to me and say, what dependencies did you have in production the umpteenth of October 2011? I go in and look in the history and give them a zip file. This is what ran the umpteenth of October. All good. You're so quiet. Let's see, did we get everything? I think we got everything. We got everything. Thank you. So, we're going to sort of fall back to the start, what I said when we began. It's time to sort of set up at least a Git strategy and start enforcing this, because the last step of our little journey through pipeline heaven is deploying stuff to production. Now, this is the last step that we will go through today. It's also the easiest step if you have done everything right. If you are using templates, which can be run as parameters, if you're using idempotent languages, whether it be Bicep or Terraform or whatever, if you have proper test coverage and everything is set up and you're using those storage blobs and everything, deploying to production is a couple of if statements away. Because we just did a deploy to production, we just renamed it. Okay? But it's also the hardest when it comes to pipelines. Because pipelines in this world, come on, let's stick together. Needs to be, well, we need to start adding stuff like parameters or variables. So we need to keep track of what to name our packages, how to version them. This is actually just a really simple version of everything. I also opted in this case to say, which package are we supposed to release in my pipeline? Why is this? Well, going down all the way down here, the deployment step that deploys to production It actually allows us to set parameters and variables so that if someone comes and say, which version was in production the 18th of September 2011, I run this pipeline and say, this version, go there, you can check it out, it runs. But I don't have to run the rest of the code. That's just CI/CD, sort of checking everything out, making sure it works. So for example, if we are not deploying a specific version, I'm supposed to be zooming now. If we are not deploying a specific, or the latest version, if we're deploying an old version, well, we don't need to run CI jobs because, well, it doesn't make sense to build an old version that we already built and stored the package of. Same here. Building artifacts doesn't make sense to do that if we didn't succeed with the CI, break as soon as possible. This is part of the whole shift left people talk about, like shifting left. Most people that talk about this talk about security, but it also we also need to consider fail fast, fail early, shift left on failing. We don't want anything to happen if we fail anything. So just break everything, stop, do not publish. We're doing our build, just like we looked at a couple of seconds ago. We upload our pipeline artifact, we download it to the next step and start using stuff like templates, because since we are using many different build hosts suddenly, it doesn't make sense to do the same. I use Bicep, I need Bicep installed. Doesn't really make sense to have 10 Bicep installs, just template it. Create our resources, run our integration tests and publish them in the pipeline and so on. And if everything works fine, we publish it. Publish it as a universal package, and we start the last stage, which is deployment. Everything went well. We packaged it, we tested it, we ran our unit tests, we ran our integration tests, we ran our load testing, everything is fine. Well, let me know if it gets too small, but I want to fit it all on one screen. Almost, at least. Download the universal package, the one we just created, or the one we specify. Set up our prereqs. Deploy our Azure function. And publish the actual function, because we need to deploy the infrastructure before we deploy the actual code to it. It's actually only 4 steps to move from dev test to actual deploy, if you do the prereqs or the pre-work good. We're going to look very quickly at a small nifty feature, the very Azure DevOps specific feature. That is, instead of running a normal job that just runs a job, we're going to run, I'm running a deployment job in this case. A deployment job has some cool features that we can add to it. So I actually triggered this just before I started this session. And let's see if we, no, wait, I'm looking at the wrong one. Here we go. How many of you people here run any kind of CAB boards, change advisory boards? No? Do you know what it is? Okay, a couple. Change advisory boards is very common when you come to companies that has security, high security. They're also quite common when you come to companies who just likes to press big red buttons. Basically, it means that someone has to approve everything that is deployed into production. Most often, they just set it up on a schedule and say, because we can't deploy 2 products in the same time. I don't know why. I never got a good answer. Also, I don't know, it's power hungry, but it's quite common. It's part of ITIL, I think it is, that implemented the change advisory board. So they're quite common. That doesn't mean I have to work, right? We can actually set up our deployment steps to use environments, so we can say that when you're deploying to production, use this environment. And if we go to that environment, this is, like I said, a very Azure-specific feature. Sorry, that was the wrong button. That's the one we're looking for. We can say all approvers must approve. In this case, all approvers means me, because I'm the only one in my environment. This will also generate an email. So if you have a CAB board, if you have someone who says, you cannot deploy when you want to, you can just send them an email and, okay, go click the button when you're ready. This will wait for 30 days. After 30 days, you're off, unless you prolong it or change the default settings. CAB advisory boards are terrible, but some people need them, and that doesn't mean I should work more. Here's an interesting tidbit, though. This is actually one of the differences that I found explained on the difference between CD and CD, as in continuous delivery and continuous deployment. Delivery means just deliver it to who's ever receiving it. So what we're doing right now is continuous delivery. If we were to remove this one, then it's continuous deployment, because it would automatically just move on to deploying stuff. Not sure I always agree on that, but it's really hard to get tech people to agree on what all our acronyms actually means. So like I said, I triggered this just before I went off. And sorry. I triggered it using a branch called release and then today's date, and 03. Wait, why did I do that? Not today's date. I triggered it on the wrong branch because I messed up. Doesn't really matter. It's the same code anyway. What I was going to say was I'm an avid lover of single branch deployments. Use small jumps, like small code add-ons. Small, push to main every single small change you do. Why? Because you will mess up, and this jump is much smaller than this one. So do smaller ones. That doesn't always work though. So set up a Git strategy, like I started with saying. You need a Git strategy because you will want to mirror your triggers with your Git strategy. So you need to know which branches are we supposed to trigger which steps on? Do we trigger builds on every new release of domain? Or like in my case, on every 4-month-old release? Because I messed up. Nope. Come on. That one. I don't know why I named it 040. I actually looked at the date and was like 0620. Nope. Okay. Anyhow, like I said, I always suggest doing single branch because it's actually sort of, once you get used to it, the most useful and simplest strategy, I think. But I also like creating release branches and actually triggering my releases from them. So I trigger this one. I create a new branch, name it release something, trigger my release cycle, and then I lock this branch down. No changes will ever be done in this branch. Why do I do it then? Well, because I'm human and can't write apparently. But when someone comes to me and says, what did your Git repo look like the umpteenth of October 2011? Oh, well, this is this release. It looks like that. It's also a lot simpler, I think, to just have a nice GUI with a nice tree that says, in date sorted, here's when we created every single release. It doesn't really fill a function, but I like it. Like I said, this is my way of doing it. Feel free to add, change, or do something else. Back to the environments. Our CAB board, super me, finally goes into this, reads his mails, does his review, and says, I have absolutely no idea what this does, and clicks approve because that's the whole point of CAB boards. And honestly, I don't think we're going to have time to wait for this because it takes about 10 minutes to deploy it to production. So I'm just going to say, it works. Believe me. Trust me, I'm a developer. Never trust a developer. Look, it's so fancy and green. Do not look at the date. So we have done our deployments. We have built our artifacts. We reuse our artifacts all the way from here to here to here. We know that the code that we tested here is the same code that runs over here, right? Every single piece of code is tested all the way through. And we have our packages that we can go back and look at and tell whomever asks us what was deployed. We can say, this was deployed. So, let's go back to our presentation. How are we on time? We're pretty darn good on time. I was not expecting this. So, the three keywords we noted: stability, repeatability, and frequency. Have we achieved them? Well, we have stability. We do testing, all kinds of testing in every single step. We have our linters. We know that code looks the way it should be. We run both our CI and our CD and everything. We have unit tests, because if you do not do CI, you're gonna end up running crap code really quick. Stuff that you don't actually properly test. If you don't do testing properly already, go back and start there, because you need it in order to run stable stuff. But if you do, stability, yes. Repeatability, well, it's scripted, it's automated. We have all our artifacts all the way through, and we can deploy an artifact from whenever to a test environment or a dev environment or whichever environment you want. I would say that's quite repeatable. We have idempotence, which means that even though our production environment is up and running, as long as nothing changes in it, my bicep code, my deployment of our infrastructure will just go there and say, oh, nothing changed. Okay, thank you. No cold starts, no reruns. I'm running the free version, so if I change the code, I have a cold start, which is why it takes so long to run the deployment, because updating code in it takes about 10 minutes right now. But yeah, it's repeatable. We can do it. Frequency. Frequency is a relative term. We can do it how many times we want. But currently, this pipeline takes about 20 to 25 minutes to run completely. But frequency and increased speed is a consequence of the rest of the stuff we're doing. I have seen way too many companies and people just start their entire sort of release cycle journey with, we need to go fast. Okay, but do you need to go good? No, fast. I've actually had customers complain to me that, like I said, I use scale sets as agents. I've had customers complain to me that the scale set startup time was too slow. That's about 30 seconds to a minute. Because they don't have time to wait for that. We need to fast. Okay, how often do you deploy? Like twice a month. Okay, up to you. I'm a consultant. I can charge you for anything. So, up until you have the rest, frequency works, absolutely. But this is the time to start looking at speed, at actually getting fast. Because, like I said, I've templated a lot of stuff. I still inject stuff into my, download modules and run them manually. That's dumb. I can use an image builder, I don't remember who presented it, to actually have them in my image to start with. That would save me a number of minutes. I could make stuff like only build the parts of my build script that I need. I don't have to build the entire module every time. I can use the Git trick to actually see that I only need to build this one or change this piece of code, right? And we can start focusing on other stuff. So, instead of focusing on sort of doing the DevOpsy stuff, doing the release pipelines and stuff, we can hopefully move from not deploying to Friday and make every day Friday, and focus a bit on GinOps instead. I have no idea what that is. I just found it on the internet and I absolutely loved it. Thank you. Any questions? Five seconds to go. Any questions? Shoot. Sorry? Get started with a Git strategy. Sorry, so the question is, do I have some resources on good strategies to get started with Git strategies as a team? Right? Yes. No resources to sort of just magically pull out of my pocket right now, but there are 3 basic strategies that people work with. You have Git version, and again, brain freeze. GitHub flow, Git flow, and single trunk development, which is what I always think is best. Single trunk development is just main. GitHub flow and Git flow, they require a lot of branching strategies and so on. They work. What's important, if you do not sort of, if your developers have trouble following them, every single instance of Git I have ever worked with have support to set this up, and it's always, or mostly always, quite easy to enforce a Git strategy in your repo. Unfortunately, it's also very easy to, or most software also just does it for one repo, so you have to redo it over and over and over again, or run it as code. So no, I do not have the carte blanche, this is the way you go. Just the KISS principle is always best. Keep it simple, and there's one more word there that I'm trying not to say right now. Keep it simple and stupid. Any other questions? Okay. Yeah. If I will share, the question is, will I share the code on GitHub? It will absolutely go. The presentation and all the YAML and build scripts and so on. I don't think there's any secret in it, so I will share like everything. So, yeah. Yeah, absolutely. Everything will be up on the PSConf GitHub page eventually. I don't know when, but I will try to get it done during the week or so. No more questions? Then I'm wishing you all a good evening and a fantastic party, and thank you very much.